Before we proceed on our discussion, let me present to you our objectives. At the end of this lesson, you should be able to define and illustrate combinations of objects, illustrate combinations of objects in real-life situations, determine the formula for combinations of n objects taken r at a time, solve simple problems involving combinations. Let's get started. Suppose you were assigned by your teacher to be the leader of your group for your math project. You were given the chance to choose 3 out of your 30 classmates to be your group mates. If you choose Julia, Gerald, and Joshua, does it make any difference if you choose instead of Joshua, Julia, and Gerald? Of course not, because the list refers to the same people. Each selection that you could possibly make is called combination. So in this case, that is just one combination, because in combination, order does not matter. On the other hand, if you choose Julia, Joshua, and Moira, that is another combination, and it's different from the first combination cited. By definition, combinations is the number of ways of selecting from a set when the order is not important. In combination, ABC, BCA, CAB, ACB, BAC, and CBA are just the same. Hence, that is just one combination. For you to understand combination, let's have an example. The students from Palawan wants to visit Tarlac, Philippines. A tourist guide suggested some of the nice places to be visited, namely Capas National Shrine, Monasterio de Tarlac, Aquino Ancestral Home, Goshen Resort, and Tarlac Recreational Park. In how many ways can the students select 2 out of the mentioned places? So, let us try to list all the possible combinations. First, they can choose Capas National Shrine followed by Monasterio de Tarlac, or Monasterio de Tarlac followed by Capas National Shrine. This is considered as one when it comes to combination, since the arrangement is not important. Next, the students can choose Capas National Shrine followed by Aquino Ancestral Home or Aquino Ancestral Home followed by Capas National Shrine. The next combination is Capas National Shrine followed by Goshen Resort or Goshen Resort and Capas National Shrine. The next combination, we have Capas National Shrine and Tarlac Recreational Park or Tarlac Recreational Park and Capas National Shrine. For number 5, we can also choose Monasterio de Tarlac followed by Aquino Ancestral Home or Aquino Ancestral Home followed by Monasterio de Tarlac. For our 6th combination, we have Monasterio de Tarlac followed by Goshen Resort or Goshen Resort followed by Monasterio de Tarlac. The 7th combination is Monasterio de Tarlac followed by Tarlac Recreational Park or Tarlac Recreational Park followed by Monasterio de Tarlac. Number 8, we have Aquino Ancestral Home followed by Goshen Resort or Goshen Resort followed by Aquino Ancestral Home. Our 9th combination is Aquino Ancestral Home followed by Tarlac Recreational Park or Tarlac Recreational Park followed by Aquino Ancestral Home. For our last combination, we have Goshen Resort followed by Tarlac Recreational Park or Tarlac Recreational Park followed by Goshen Resort. By listing all the possible combinations, hence, we have 10 ways can students select 2 places out of the 5 mentioned places. Listing all the combinations of n objects taken r at a time is time-consuming. That's why we have the formula that we can use to find the number of combinations of objects. The formula for combinations of objects without repetition can be illustrated in the form of combination of n, r is equal to n factorial over quantity n minus r, quantity factorial, times r factorial, wherein n is the total number of objects and r is the number of objects taken at a time. Let us try to use the formula in our previous example to check if we got the correct answer. How many ways the students can select 2 places out of the 5 mentioned places? We can say that our n is equal to 5 since we have a total of 5 places, and r is equal to 2 since we are selecting 2 places at a time. Now, we can substitute the given values to the formula. So we have the combination of 5, 2 is equal to 5 factorial over quantity 5 minus 2 quantity factorial times 2 factorial. We can now evaluate our equation by computing first the operation inside the parentheses. 5 minus 2 is equal to 3. So we have 5 factorial over 3 factorial times 2 factorial. Expand both the numerator and denominator. So we have 5 times 4 times 3 times 2 times 1 for 5 factorial, 3 times 2 times 1 for 3 factorial, and 2 times 1 for 2 factorial. We can now cancel 3 both on the numerator and denominator, and cancel 2 on the numerator and another 2 on the denominator. Let's multiply the remaining factors. 5 times 4 times 1, we have 20, and 1 times 2 times 1 is equal to 2. Last step, 20 divided by 2 is equal to 10. Thus, we have 10 waste. Therefore, using listing method and the formula for combinations, we can say that the students can select 10 different waste. Let's try to solve another example. In how many ways can an examination committee of 4 be chosen from 9 teachers? Because order has nothing to do with the membership in the committee, we can solve this using combinations. Let us first identify our n and our r in the given problem. Since we have a total of 9 teachers, then n is equal to 9. Also, we're going to choose 4 examination committee. Thus, r is equal to 4. Given the formula, combination of n, r is equal to n factorial over quantity n minus r quantity factorial times r factorial, we can substitute the given values. So we have combination of 9, 4 is equal to 9 factorial over quantity 9 minus 4 quantity factorial times 4 factorial. Simplifying the equation, 9 minus 4 is equal to 5. We can write our numerator 9 factorial in the form of 9 times 8 times 7 times 6 times 5 factorial, so that we can cancel 5 factorial on the numerator and on our denominator. We know that 4 factorial is equal to 4 times 3 times 2 times 1. By getting the product of the factors of the numerator and denominator, we have 9 times 8 times 7 times 6 is equal to 3024. And 4 times 3 times 2 times 1 is equal to 24. Last step, 3024 divided by 24 is equal to 126. Thus, we have 126 ways can an examination committee of 4 be chosen from 9 teachers. Let's have our last example. In a class of 25 students, there are 10 boys and 15 girls. How many ways can a committee of 3 boys and 2 girls be formed? In this example, we're going to start by getting the number of ways committee can select 3 boys and the number of ways a committee can select 2 girls. So, 3 boys can be selected in combination of 10, 3 ways. Since we have 10 boys and we're going to select 3 boys. Next, 2 girls can be selected in combination of 15, 2 ways. Since we have 15 girls and we're going to select 2 girls. Using fundamental counting principles, we can find the number of ways can a committee be formed using the combination of 10, 3 times the combination of 15, 2. Let's start solving combinations of 10, 3. In our given, 10 is our n and 3 is our r. Using the combinations formula, combination of n, r is equal to n factorial over quantity n minus r quantity factorial times r factorial. We can now substitute the given values. So we have combination of 10, 3 is equal to 10 factorial over quantity 10 minus 3 quantity factorial times 3 factorial. Let's compute inside the parentheses. We have 7 factorial coming from 10 minus 3 quantity factorial. Our next step is to rewrite the numerator in the form of 10 times 9 times 8 times 7 factorial. To cancel 7 factorial on the numerator and denominator. Multiply the remaining factors. 10 times 9 times 8 is equal to 720 and 3 factorial is 3 times 2 times 1 which is equal to 6. Last step, 720 divided by 6 is equal to 120 ways. Now, let us solve combinations of 15, 2. In our given, 15 is our n and 2 is our r. Using the formula for combinations, let us substitute the given values. So we have combination of 15, 2 is equal to 15 factorial over quantity 15 minus 2 quantity factorial times 2 factorial. After substitution, let us evaluate inside the parentheses. 15 minus 2 is equal to 13. So we have 15 factorial over 13 factorial times 2 factorial. 15 factorial can be written in the form of 15 times 14 times 13 factorial, so that we can cancel 13 factorial on the numerator and on our denominator. Let us now multiply the remaining factors. 15 times 14 is equal to 210 and 2 factorial is 2 times 1 which is equal to 2. 210 divided by 2 is equal to 105. So we have 105 ways. Since we already have the values of the combinations of 10, 3, and the combinations of 15, 2, we can now substitute the given values. So the combination of 10, 3 is equal to 120 times the combination of 15, 2, which is equal to 105. 120 times 105 is equal to 12,600 waste. Thus, we have 12,600 waste can a committee of 3 boys and 2 girls be formed. I want you to remember that when it comes to combinations of objects taken all at a time, which means n is equal to r, it's always equal to 1. Meaning, combination of 5, 5, combination of 10, 10, combination of 37, 37, combination of 1000, 1000 are all equal to 1.